Hello, I'm Bronis Stosipinski, and I'm the chair of the OpenMP Language Committee. And today I'm going to give you an update on recent and upcoming activities of the committee, and in particular, our focus on producing OpenMP 6.0. As you may have heard, we recently released TR12, which is our latest preview release of of 6.0. So our plan is to release the actual 6.0 version next year at this time. And we're pretty confident at this point that we will meet that goal. That as the TR that we've just released really demonstrates the level of progress we would expect to be for being a year out from the final version. We've already identified several major new features, and importantly, we've actually adopted several of those. The most significant one that I'll be telling you more about in a few minutes is something we call free agent threads, and that really represents a pretty significant set of changes to our execution model, and it will also require implementations to make some pretty major changes to how they manage task level parallelism. We've also added a feature that may seem small in and of itself, but it really significantly expands the way we support parallelism on loop-oriented parallelism, and it is a very descriptive construct. I'll say more about that shortly as well, and that's the induction clause and user-defined induction. We continue to make a lot of improvements to device support, as we have been doing ever since we first adopted support for using devices besides the host in OpenMP 4.0. Many of you probably know this is OpenMP offload, and I'll briefly touch on some of those and probably refer you to other talks to learn more about them. And finally, we've really been working to make it so that the specification is much improved, and a number of other changes that will also make it a lot easier to use the language. All in all, we've already completed 153 issues. We actually have adopted 2 more since the TR12 content was completed. Those were fairly small ones, but they were not done quite in time to get included in TR12. And there are over 300 others that are under consideration. Most of those will not get included in 6.0, I expect, but many of them will. And when we include the ones that will, as well as issues that represent our quality control work, that will be the final stages of the 6.0 process, and will come after we release TR13 next summer. I expect this to be up around 250 issues in total for 6.0. So I'm going to tell you more about free agent threads in a second, but it really is a way that you can better use top-level parallelism and the resources that are available in the system. Some of the improvements that we've made for use of a single device include ways to better specify the default device and control the visible devices that might be used for offloading execution to. We've really been working hard at improving the use of device memory. So group private is a way to basically specify that the use of device shared memory, which is a little confusing given that it's not the shared memory that has always been supported in OpenMP, but it is what GPU devices often call shared memory. So that's available through group private, and that was already adopted last year in TR11. We've also added this concept of self maps with the self map modifier, and that's a way to be able to say don't create copies when possible. And so that's also a pretty significant addition. So on one hand, we're saying here's the exact device memory that we want to use, and then on the other hand, we're saying just use the system memory and make it something that I can access from both the host and the device. And we've also improved the way allocators work, and I actually expect that we'll have more. Another big feature that we've added is for Fortran only, and that's the co-execute directive, which provides real support for offloading array language, array notation to devices. So to set the background for free agent tasks, we have, I want just to remind you of the OpenMP tasking execution model. As with any tasking model, it provides a way to support unstructured parallelism. And as you see in this example, you create a parallel region, and then typically within that parallel region, you limit execution to one thread that actually generates the tasks. And then those tasks can be executed by really any thread in the team. All right. And so you might ask, why are the parallel and single directives needed? And it relates back to how tasking support was added to OpenMP that already had support for structured parallelism as represented by parallelism across loops. So the work sharing loop directives in particular. Well, if we don't use these, first of all, if you don't use the single directive, otherwise all threads in the team generate duplicate tasks, which is typically not what you're going to want to do. All right. Further, if you don't actually use a parallel region, then you won't get any parallelism. All right, because only threads in the team may execute tasks. All right. So you can ask, is restricting tasks to a team good? Well, it simplifies resource management. It has clear semantics with respect to other teams. All right. It says, here's the threads that I want to use to execute these tasks, and only those threads are going to execute those tasks. And if I bind those threads to specific resources, then I'm guaranteed that execution of those tasks won't interfere with any other work that's being done. The negative aspects is if you aren't fully using those resources, either because you're not using nested parallelism or because some of the other nested parallel regions have completed, then you're not using all the resources that are available. And also, if your program is only a task-only program, if you're only using tasks, then the code structure is significantly complicated. So an alternative is to use free agent threads. And this allows unassigned threads in a contention group to execute tasks, as well as those threads that are assigned to the team in which the tasks are created. So this can provide parallelism in the implicit parallel region, and it also it can exploit unused resources, which is and makes use of the common practice of parking threads in most implementations. So here we see an example where we have free agent threads. We don't need to provide a parallel directive. Instead, we can simply just say this task the thread set on which this task can execute is the OMP pool, which is all of the threads that are available in the contention group. So what we see here is we have this contention group, and here are the threads that exist for that contention group. And as we generate tasks, any of those threads can pick up the tasks and execute them. And so how does that end up working? Well, here are some details. First of all, we've preserved the existing behavior by default. So you can also specify the thread set with the keyword OMP_team, and that says restrict this thread to only being executed by tasks that are actually assigned to the team. All right. So in addition, tasks are still tied by default. So even a free agent thread, even a task executed by a free agent thread will only be executed by the thread that begins executing, even if that thread suspends execution of the task to execute a different task. So the task synchronization construct, dependencies, task weight, task group, barriers, all the things that you've been using to synchronize tasks still work the same, whether it's a free agent thread that's executing the task or it's an assigned thread in a team. So you get clean semantics, and you can actually mix threads that can be executed by free agent tasks that can be executed by free agent threads, and tasks that can only be executed by assigned threads in the same parallel region. And note that, as I mentioned before, even the implicit parallel region has that ability, because you have the initial thread that is assigned to that initial implicit parallel team. And then you have all the rest of the threads in the contention group. In addition, you can use environment variables, as we see here, to partition threads between being used for structured parallelism and unstructured parallelism as free agent threads. And in this example, you're guaranteed that you always have 2 threads to execute structured parallelism and 2 threads to execute as free agents. And if you have more, if you specify a thread limit that's higher than 4, then the remaining threads can alternate between being assigned to teams, and if they're not currently assigned to the team, executing as free agent threads. All right. And I note here that the minimum for structured parallelism is 1 thread, the initial thread. So that initial thread is always considered to be one of the structured threads. Now, I also note that the sum of the reservations should not exceed whatever you specify as a thread limit. If they do, then essentially you'll get implementation-defined behavior. We've added several other things already through TR12. In particular, we've been adding additional loop transforming directives that really allows OpenMP to serve as a way to program your compiler. And so you can tell the compiler specifically optimizations that it should apply to specific loops. And we've added a couple new directives, loop transformations, loop transforming directives to 6.0. We expect to probably add some more before 6.0 is finished. And we've also added the apply clause, which allows you now to have a loop transforming directive generate loops, and then you can specify directives to apply to those loops. We've also added induction, as I mentioned. Really, you can see this as a way to specify that a variable has the behavior, has the progression through the iterations of a loop that might be specified through the increment operator on a loop. And so this means that you can actually capture things that would not be allowed in a canonical loop form. But you can actually tell the compiler this variable has this well-defined behavior, and so now I've captured a cross-iteration dependence in the loop, but in a way that allows the compiler to handle that and parallelize it. One of the key things is that you can specify a collector function for that variable, and that way the compiler can generate the value at an iteration for a specific iteration without having computed all of the previous iterations. So it basically allows you to break the dependence. So we have extended the parallel directive to support better user control of the number of threads. And we've done this by adding a new modifier to the num threads clause and two new clauses that can be specified for the parallel directive. So the prescriptiveness modifier can take two different values, strict and relaxed. Strict requires n threads to be provided. If you don't specify strict, then the existing behavior that in the end really means that the number of threads can be implementation defined, because the implementation determines how many threads are busy. Otherwise, but if you specify strict, then you will get the number of threads that you've requested. If the implementation determines that it cannot provide that number of threads, then an error will result. And by default, you'll get termination. The program will terminate if you don't get that number of threads. You can specify a severity level of just warning through the severity clause that's available on the error has been available on the error directive, in which case only a message will be printed. And you can use the message clause to augment the message that the implementation will provide. All right. Anyway, so that's the main change. That's actually a pretty significant change, although it's a small change in other ways. And in addition, we've now allowed you to specify n threads as a list, which means that in addition to changing overriding the immediate value in the n threads var, you can now also override additional values in that n threads var list, so you can actually control how the nesting will be handled. We're going to actually have several additional improvements in OpenMP 6.0, some of which have been adopted, others of which we are intending. It's possible that we'll further extend this descriptive and prescriptive control similarly to how we've handled things with the num threads clause. We've removed all of the features that were deprecated in 5.0, 5.1, and 5.2. That's a pretty significant set of changes because we had actually deprecated a fair number of features in those three versions. And so we're following through on our commitment that when we deprecate a feature, it will be removed in the next major version, which 6.0 is relative to those changes. We may still be able to add dependencies and affinity for the task loop construct. We've been working on that a lot. It's more complicated than we originally realized when we thought we'd be done very early in the 6.0 process. The tasking subcommittee continues to work on that feature and have recently made some real progress. You can see here we're working to respond to requests to make OpenMP support for C++, more C++ like, and we're doing that primarily through the attribute syntax. We'll also be supporting attribute syntax in C, since that's been adopted in C23. Anyway, other changes that we expect to make, we're working hard right now on refining how combined constructs are specified, so that they're specified on properties, which will hopefully make the availability of a combined construct much more evident, because it'll be much more based on a rational definition of, if you can specify these constructs one inside the other, then you can specify them as combined constructs. The implementers have asked for some additional restrictions on the ability to combine constructs, and we're currently working through just how we can make it so that it's intuitive that you can combine constructs while respecting their request that we not make it overly broad. We're also very much working to further clarify that OpenMP, its execution model is really a task-oriented execution model. And that will end up actually having some changes that hopefully will further improve support for devices, in addition to just generally making that the execution model is a task-oriented execution model. We're working to further improve the specification. We've done a number of things that already make it clear that we feel make the specification better. All the clauses now accept arguments. They also, many of them have default arguments, so you can actually specify them without any arguments or modifiers. But now all of the clauses can also accept modifiers, which will make it a lot easier for us to define how clauses work with combined constructs in particular, which we do through this directive name modifier. So the immediate focus is several high priority, nearly completed issues, the combined construct rationalization being one of those. We're also working on many improvements for single devices, as well as improvements to tasking. We have other ways that better control the number of threads and how those are bound to system resources, to places, as we call them, and basically better control of defaults. So whether it's default for sharing, for data sharing, characterizations of variables, data mapping, or any of the many other defaults, we're working on ways that users can control those defaults more cleanly. There are many things that we've had proposed that we think are probably good ideas still in the long run. So it's not that we're not doing them because we rejected them as bad ideas, but really because the amount of things that both we can complete for the time frame in which we will be releasing 6.0, in which we want to require implementers to support in the next big movement forward for the specification. We want to limit that so it's reasonable for them to implement. So there's many things that we probably won't get done in 6.0. One of the big things that I think will probably happen in 7.0, maybe even 6.1, is beginning to provide better support for using multiple devices. We know that many people are interested in this. We actually will make some improvements, but for use of multiple devices, I expect in 6.0. But we won't do things like support for bulk launch, almost certainly, and things like broadcast and multicast from one device to a set of other devices. Anyhow, these things all, as I mentioned, would be useful, but they are not likely to get done in 6.0 due to the limited nature of what we can complete. Anyhow, so, hopefully you'll be able to, you see the features you want. If you don't, then, you should let your representative on the OpenMP language committee know, and we will try to get it in there. But as I mentioned, there's only so many things that we can reasonably do. And with that, I'd like to thank you for listening.